Okay, what we're going to do here is we're going to look over some homework questions on hypothesis testing. And this is going to be hypothesis testing about a mean for a large sample. Okay, so we're looking at the sample size greater than 30 for a large sample here. So we're looking really at the homework that people were trying to talk about doing last week. So I'm going to start with actually question number 8 because that's actually hypothesis testing about a mean. Okay, so let's move this up here on the worksheet. So we got hypothesis testing about a mean. That's number 8. That's actually number 9. It should be also hypothesis testing about a mean 10, 11, and in fact 12. Okay, so we're going to try that question number 8. Now, let's read this here. A health of employees is monitored by periodically weighing them in. A sample of 54 employees has a mean weight of 183.9 pounds. Assuming that sigma is known, that's the population standard deviation, to be 121.2 pounds, use the, notice what it says now. We're going to use the 10% significance level to test the claim. Now, the claim is coming next. What are they claiming? They're claiming that the population mean, this is mu, of all employees is less than 200 pounds, right? So this is mu less than 200. So I'm going to write that down. Mu less than 200. This is the claim here. Okay? So we have a claim. Mu is less than 200. So I'm going to go back here on a scratch, and this is question number 8. Mu less than 200. This is the claim now. Okay? So we have to determine where to put the claim. If it involves a condition of equality, it's a null hypothesis. If it lacks the condition of equality, it's an alternate. So since there is no equality, your claim is an alternate hypothesis for number 8. There's no equality there. The opposite of this statement, and then this is not an M though, this is a mu, it's a Greek letter, that's greater than or equal to 200. So you have to have these opposites, ladies and gentlemen. And sure enough, here we go. Let's start with this. Good. So here's our setup. We're going to have to create the decision rule now for this. And you always look at the alternate hypothesis. That's strictly less than. And since it's pointing to the left, it's a left-tailed test. So we're going to label our decision rule. The non-shaded region, do not reject your null. The shaded region, you reject the null. Okay, so far so good. Love of significance. We're going to have to go back to that sheet. Right? They said use the 10% level of significance. 10% right in here. So what that means here is alpha is 10%. So, okay. That means 10% is in this tail here. Because remember, you need a critical value for your decision rule. So you're going to have to find a critical value. Now, since it's a left tail test, there's only one critical value. Right? So this is that homework question number 8 we're looking at. So we're going to use the default. And you say, what's the default? Well, I guess we can use a couple of things. Area to the what? Area to the left in our TI. So here's the old default stat variable. We need to use the inverse norm to get critical values. Now, area to the left is 10%. So we go 0.10 is 10%. This is the Z distribution, the student distribution. Mean is 0, sigma is 1. And this is going to give us our critical value. It's negative 1.28 here. Okay, so when we label this using the default on the TI, you're going to use the fact that, you know, alpha is 10%. 10% is in that tail here. Okay. Yeah. All right. Now, let's say, for example, you say, I don't want the default. I'm going to change the calculator here so you can see it in both ways, at least initially. I'm going to clear that out. We're going to say second distribution. We're finding a critical value. Remember, that's inverse norm. Now, this is a left tail, so I'm going to put the 10% here. Mu is 0, sigma is 1. Yes, that's 10% of the area is in that tail. It's a left tail. And then sure enough, you're getting the same thing. So maybe you want to, I'm going to make this a little bit bigger for us here today so you guys can see, hopefully clearly, what we do. And as you can see, it's the same critical value. So, okay, fantastic. We're good to go now. There's that critical value. Okay, so remember what you really need to do next in the process. Now what you would do is go out and take a sample. And since this is going to be on a hypothesis test about a mean, we're going to need to know the sample size, the sample mean, the sample standard deviation, and we're going to need to know this thing called mu naught. Okay? Because we're going to enter all this in our TI. So let's go back and read here. Read. Oops, it's not here. It's right in, I have it right here. Hypothesis testing. There we go. Nope. There it is. So number 8. I'm going to write down the sample information. Say, here's my sample. Sample size is, when I go back and read it, right? Sample of 54 employees. Sample size is 54. They have a mean, that's a sample mean of 183.9 pounds. So this will be 183.9 pounds. And then they say, okay, assume sigma is known. So that doesn't really come from a sample. That's 121.2. So I'm going to write it as 121.2. This is known for some reason. Somehow it's known. And I'm going to copy this. So now we go back to our scratch. And let's enter this here. 54. 183.9. This is 121.2, and this is going to be that sigma now. So don't forget something important here. You say mu naught. Well, that's the mean from the null hypothesis. So that is going to be 200. So that's the mean from the null. So this is going to be 200 now. Okay, so we're going to enter all of this in our TI. The whole idea is to use the TI calculator on this, I guess. And let's go back here and remember here, right? We're going to hit stat, wrong, stat, test. Remember, this is mean, and it's using z-test. It's that first entry. This is going to be using the z-test, ladies and gentlemen, for hypothesis testing for a large sample. We're going to use, this is what we use, the z-test. And this is what we had in lecture. Okay? We're going to get a z-value. We're going to get a critical value. And we're going to see where this lives in our decision rule. So remember, the critical value is to the nearest hundredths. So we're going to approximate that test statistic to the hundredths. Okay. So let's enter. So make sure it's on stats, not data. Now that mu naught we know is 200. Sigma is known. It is 121.2. Sample mean is 183.9. And then the sample size is 54. So, ladies and gentlemen, remember this is a two-tail test. Oh, sorry, it's a left-tail test. I apologize. Go back and look at the picture. Left tail. It's a single tail. It's a left tail. Hit enter for the left tail. Scroll down and hit your calculate. Now, here's our test statistic, and it's negative. So it's negative 0.9, not 7, but 98. Okay? So here's the test statistic. Now, the question is, where does this live in our decision rule, right? Where does this all live? So notice any test statistic that is larger than negative 1.28, we do not reject the null. So this is going to be, first of all, it's to the left of 0, but it's not quite past negative 1.28. That's not even 1. So this is kind of where my test statistic would be, I guess. Not really, but 0.98, and it's negative. So, okay. So where does that live? That lives in the orange region, meaning do not reject the null. So if you're not going to reject the null here, remember this. This is the null. We're not rejecting that null. If you're not going to reject the null, you are accepting the null. And I think we were traditionally using highlighters here. Let's see if it helps. Now, the real question is this, because we're going to accept the statement that the mean is at least 200 pounds. Remember what your claim was. The claim is it was less than that. So, ladies and gentlemen, here's what we can say. We're accepting the claim, but we have to reject the alternate. And in conclusion, we simply say the sample does not support the claim because we rejected the claim. Okay, the claim was crossed out. The sample does not support the claim. So now let's check, ladies and gentlemen, this is question number 8. Let's check these solutions here. So this is from past homework. Let's see what the solutions, people who wrote this down, say. They go, oh, okay. Yeah, that's really, if you notice the null and the alternate hypothesis, mu is less than 200. They kind of got a bit lazy. That's supposed to be greater than or equal to. They just use the equal sign, and they try to deduce this. It looks like this test statistic is fine. Fail to reject the null, that's accepting. Failing to reject the null is to accept the null. And then now what they're saying is there is not any evidence to support the claim, to warrant the rejection of the claim. There is not enough evidence to warrant rejecting the claim. Well, whatever. That's very simple or very similar. I prefer to just simply say this: the sample does not support the claim. I cut to the chase. Okay? All right. Sample does not support the claim. Okay, fine. Now that's question number 8. Okay? Now we're going to go to question 9 here. We're going to see how that works now all over again with this. We're going to now start question 9, but I wanted to make sure I covered 8 because people ask about that one and go, hey, what about this one? Well, this is hypothesis testing about a mean for a large sample. We're now going to go to number 9 here. And personally, we might just do the odds. We'll see. Okay, so, they're saying here in your instructions that you are going to, test a claim here. And if we read this, a test of sobriety involves measuring the subject's motor skills. Okay. This is going to be an issue for us. We can't do number 9 here because this is for a small sample here, but let's double check. Yeah, number 9, it should be a t value. Yeah, that's a problem here. So let me remark here. It's good to talk about this. We might even do others here. Now, I save this for a separate section. 20 randomly selected. This is a sample size of 20. So I actually use this in another section. So this is for a small sample situation. And then that's using the student distribution. Okay, so you're going to skip this because I want to do means here. Hypothesis testing for means for a large sample. So I'm going to say skip and wait for that video. Skip 9. So it looks like we will do 10. Hopefully 10 is a large sample. So we will do number 10. It's good to go through this stuff. All right, let's see what number 10 says. A large company gives job applicants a test of programming ability, and the mean for the test has been 160 in the past. Okay. Software company gives applicants a test of how well they can program, and the mean for the test has been 160 in the past. Okay, let's see what we can do with this. Right. 25. Oh, we have small sample again. So where is the large sample? Is that the only question? Hope not. Anyway, so 25 job applicants. Oh, guess what that means again? Small sample. Anything under 30, less than or equal to 30. That's a small sample question. All right, we're going to have to wait till later. Boy, hopefully we can skip them all. Okay, let's see. Hopefully, yeah. Nah, it looks like these are all small samples here. So 9, 10, 11, 12 are small samples. Obviously, these here are also small samples. So we will now need to change your homework until the day we go with the small samples. Let's see if number 15. Yeah. All right, we're going to have to skip that. Anyway, yeah, it looks like these are small samples there. So not quite sure what happened when I wrote this. Only one question was a large sample, question number 8. Well, it looks like that's the case. Okay, I apologize for the confusion. So, I mean, I'm sure you guys will you'll like the good news for this. So you only do question 8. All right, thank you, and we will see you guys later.